Alright, so we have an example of the equations that we need to solve where the imaginary system will come in. So if x squared plus 1 equals 0 has no real solutions, because you can tell what's going to happen. When you subtract both sides by 1, you get a negative 1. So you have x squared equals negative 1. Then you take the square root, and that's where the issue comes in. So we're defining them as imaginary numbers. In the imaginary unit, we use the letter I. So when you see the I, that means you're in the imaginary system. And I is equal to the square root of negative 1. Since we don't, in the real number system, there's no value of the square root of negative 1, so we're going to call it I. Once you have an I in there, you've now moved into the imaginary system. Okay, a pure imaginary number is written in the form bi, where b is some number like 3, 4, 5. So b is the real number, and I is the imaginary part. You have two parts, and that's where the word complex comes from. Just two parts and one. When you get to something that's a square root of a negative number, like you're seeing down here, we're first going to rewrite it by pulling the negative 1 out. Okay. Step 2 is to break down a if it's not a perfect square, just like we were doing in the warm-up. You're going to simplify it the same way you always have. When you simplify the radical, you have to remember that the square root of negative 1 is where the I comes in. This will make more sense once we do a couple of them. Number 1, we have negative 9, or square root of negative 9. So you're first going to rewrite this. I'm going to do it a little bit different than they did. I want you to rewrite it as the square root of negative 1 times the square root of 9. I'm not going to leave it all underneath the radical. Square root of negative 1 times the square root of 9. Square root of negative 1, we already said that's what I equals. So we're going to replace the square root of negative 1 with I. And then what's the square root of 9? 3, yeah. That would be times 3. If you have a perfect square like this, the final answer we write is 3i. Just like we would write 3x or 4y or whatever it is. We almost treat it like a variable. If you still have something underneath the radical gets written last. And you'll see that here in a little bit. Everybody okay so far? Alright, let's try one. That 196 you can tell is not a perfect square, so let's do that one. We're going to rewrite this so that we have the square root of negative 1 times the square root of 196. 196, is that a perfect square? Let me think. Is that 14? It is. I misspoke and said that it wasn't perfect. So the square root of negative 1, what would that be? I. Square root of 196? Okay, and then how do I rewrite it? 14i. Notice that we're not writing plus or minus yet. That's not until we get to the equations. Alright, 3, now we get into a non-perfect square. Let's rewrite it. Square root of negative 5, rewrite it as the square root of negative 1 times the square root of 5. Square root of 5 cannot be simplified. It's not a perfect square and it doesn't break down. Square root of negative 1 becomes I. You still have the square root of 5. When it's like this, when you still have that radical, I want you to leave the I first. So it gets written second when it does break out of the radical and you no longer have the square root symbol. If you have the square root symbol, it's I square root of 5. And that just keeps it neater so that we know that I is not underneath the radical. Any questions so far? Alright, we'll do number 4 together. Number 4, we have the square root of negative 80, so we're going to rewrite it as the square root of negative 1 times the square root of 80. What do I do with the square root of 80? Yeah, we're going to find the factor trees. I'm going to do that over here so I have room. What does the square root of 80 break down to? 2 and 40, good. And what can I break 40 down to?
22.
I'm going to write 2, then 20, but it really doesn't matter. And then 20? out and become 1. One more pair of 2's break out and become 1. The 5 stays underneath the radical. Now 2 times 2 gives us 4 square root of 5. So now we have negative 1 is I, and then we have 4, and it really looks like this. So we got to rearrange these so that it looks nice and neat. So we have I times 4 times square root of 5. What I want you to do when you have all 3 components, you have a number outside the radical, and the I. We write it with the 4I and then the radical 5 in that order. I want you guys to try numbers 5 and 6 on your own. What did you guys get for number 5?
4.
Very good. Does anybody need to see number 5 in its entirety? Everybody get that? Okay. How about number 6? What did you guys get? I heard a couple of, I think I heard a different answer. It should be 8I. I know I heard this. Square root of 3. Anybody want to see that one? Who said wait?
Oh, never mind.
Any questions on 5 or 6? Anybody need me to do that one out further? Alright. So if you only have a square root, you're simplifying. Again, you only get the positive root. Now we're going to be moving into equations, so now's where we got to use that plus or minus. So for this first one, what would my first step be to solve for x squared? Not yet. What do you mean separated? Oh, yes, I'm sorry. Now I know what you mean by separated. So x squared is equal to negative 81. And what's my next step? Square root it, right. So we're going to have x is equal to plus or minus the square root of negative 81. Now we're going to simplify the square root of negative 81. What should I get? Plus or minus, and what did you say? 9I, I think I heard. Remember, this is square root of negative 1 times the square root of 81. So the negative, square root of negative 1 becomes I, square root of 81 becomes 9, and plus or minus. Any questions on number 7? Kind of doing the same thing, but a little bit more involved. All right, let's do number 8. What's my first step with number 8? Separate or subtract, right? I see what you're saying now. So we have 2x squared. What will 2x squared equal? Negative 8. Now what should I do? Very good. So x squared will x squared equal? Now the next step. Square root it, right? So we have x is equal to plus or minus the square root of negative 4. Which is the same, good, as saying square root of negative 1 times square root of 4. Addie, what did you get? 2y. Plus or minus 2y. How's that feel so far? Good? Alright, let's look at number 9. I need to subtract the 15 first. So negative 9 minus 15 would give me negative 24. What would my next step be? Divide by 4, right? So we have x squared is equal to negative 6. Very good. We have x is equal to plus or minus the square root of negative 6, which can be written plus or minus square root of negative 1 times square root of 6. What do we know about the square root of 6? Right, because when you break it down, you get 2 and 3. Well, 2 and 3 are prime, so you have no buddies. There's no perfect square factor within 6. So your answer, the square root of negative 1 becomes I, and then you leave it as square root of 6. plus or minus I times the square root of 6. Seem doable? Okay, I don't know. Still wondering. Well, let's do number 10 together. What's my first step? Very good. So x squared would equal negative 12. Now what do I do? Very good. So x is equal to plus or minus the square root of negative 12, which is the same thing as saying plus or minus square root of negative 1 and square root of 12. What do I need to do to the square root of 12? Yeah, what are my factors of 12? What's one pair? Yeah, 6 and 2, and then 6 breaks down 2. Very good. So a pair of 2's come out and become 1, and 3 stays behind. Okay, what did you say?
Plus minus 2i.
Plus or minus 2i times the square root of 3.
That video made it seem like it'd be a lot harder.
We are doing the basics, you're right. So she was taking it to quantum computing and all of that, quantum physics. We will not be doing quantum physics right here. Mainly because I don't think I could teach quantum physics. So your teacher doesn't understand it. Alright, number 11. What should I do first? Yeah, we're going to add the 5. What is negative 446 plus 5?
Negative 441.
Wonderful. And my next step. Very good. What is negative 441 divided by 3? Very good. Negative 147. And my next step. Square root. Very good. I'm going to do x is equal to plus or minus the square root of negative 147, which is the same as plus or minus the square root of negative 1 times the square root of 147. Alright, let's go ahead and handle 147. What are factors of 147? I heard 3 and 49 first. You said 7 and 21. Alright, then 49 breaks down to 7 and 7. If you did 7 and 21, then you would break down 21. You did the same thing.
It's the same thing, right?
So this would be 7 times the square root of 3. So now we're going to put that back in. If the square root of 147 is 7 square root of 3, what would my final answer look like?
X equals plus minus 7i square root of 3.
Perfect.
Why didn't you multiply the two sevens?
Because when they're a buddy pair and they break out, they're bonded together on the outside, you only write up one.
Oh, so if there's two sets of 7, you can do that.
Yep. You can also think of it as this. If you have 3 and 49, what you're doing is taking the square root of each of them. Well, the square root of 49 is 7, and then 3 stays underneath the radical. Alright, let's handle number 12. 12 has a fraction in it. What would I do first in 12? Add the 1, so we have negative 2/3 x squared equals 18. What do we do with the negative 2/3 now? Very good. We're going to multiply both sides by negative 3/2. You can also divide by negative 2/3, but that's the same as multiplying by the reciprocal. So 18 divided by 2 gives me 9 times negative 3 gives me negative 27. So now we have x squared is equal to negative 27.